November 27, 1944, Isley Field, Saipan, Northern Mariana Islands. The construction lights still burn across the airstrip as dawn approaches, illuminating rows of Boeing B-29 Superfortresses, each one a $600,000 aluminum giant capable of reaching Tokyo. But three of those giants now sit destroyed, burning wreckage scattered across the runway from a Japanese air raid just hours earlier. 11 more are damaged. The attack came as a complete surprise. Brigadier General Haywood S. Hansell, commander of 21st Bomber Command, stands at the edge of the bomb crater that now interrupts his primary runway. The hole is perhaps 20 feet across, its edges jagged where the 500-pound bomb tore through the steel matting and the coral beneath. Around him, 100 Seabees swarmed the damaged site like ants rebuilding a disturbed nest, but these men move with practiced precision. They're pulling up twisted sections of perforated steel planking, the Marston Mat that forms the runway surface, and replacing them with fresh panels hauled from stockpiles positioned every 1,000 feet along the strip. 40 minutes, Hansell thinks, checking his watch as the repair crews work. They said they could patch a bomb hit in 40 minutes. The mathematics are brutally simple. His second raid on Tokyo departed just yesterday, 81 B-29s loaded with incendiaries, climbing into the Pacific sky to strike the Japanese capital 1,500 miles to the north. Those aircraft will return in approximately 4 hours, low on fuel, some likely damaged by flak or fighters. If this runway isn't operational, crews will ditch at sea, men will die. Around him, the Seabees work in organized chaos. Teams of 4 men carry the replacement panels, each one 10 feet long, 15 inches wide, weighing 66 pounds, and lock them into place with sledgehammers, the distinctive clang of steel on steel ringing across the pre-dawn darkness. The damaged panels are pulled free and tossed aside, their perforated surfaces twisted by the blast. Fresh sections slot into the gaps, hooks engaging slots, the entire surface interlocking like a massive jigsaw puzzle laid across crushed coral. 20 minutes have passed. The crater is half filled. Coral aggregate is being dumped and graded, creating a level surface for the steel. The Seabees don't slow down. At 35 minutes, the last panel locks into place. A steamroller makes 3 passes, compacting the coral beneath, ensuring the surface can support 65 tons of landing B-29. At 40 minutes exactly, the repair foreman signals completion. Hansell walks across the patch. His boots ring on steel. The surface feels solid, no give, no warning that 12 hours ago this section of runway didn't exist. He looks down the length of Isley Field, 8,500 feet of perforated steel planking stretching toward the jungle, each section identical, each one interlocking with its neighbors to form a continuous surface capable of launching and recovering the heaviest bombers in the American arsenal. The runway had been completed just weeks earlier. Before the Marston Mat, it would have taken months to build a concrete runway of this length. Months the Marines and soldiers didn't have while fighting to secure Saipan from its Japanese defenders. The broader context is staggering. Across the Pacific, from Guadalcanal to Tinian, from New Guinea to the Philippines, American forces are building airfields at a pace the Japanese never anticipated. Henderson Field on Guadalcanal, the massive complexes on Tinian. North Field alone can accommodate over 200 B-29s, dozens of fighter strips scattered across captured atolls. Every one of them depends on this humble innovation, perforated steel planking that can be laid in days instead of weeks, creating bomber-capable runways on coral sand where conventional construction would be impossible. The Japanese had planned their Pacific defense on the assumption that American airbases would require extensive construction time, concrete poured, cured, and finished using methods that took weeks or months. That assumption was about to cost them everything. But the Americans had brought something unexpected to the Pacific, something the Japanese never anticipated. If you want to see how this single innovation rewrote the war in the Pacific, support us with a like. It helps us uncover more buried stories like this. Subscribe if you haven't already. That unexpected innovation? A runway in a box. The journey to this moment had begun more than 3 years earlier in the humid forests of North Carolina. November 1941. Camp McCall, Marston, North Carolina.
2 miles northeast of a whistle-stop town on the Seaboard Coastline Railway, Army Corps of Engineers combat engineers from Langley Field are constructing something that doesn't look like a traditional runway. The strip measures 150 feet wide and 3,000 feet long, but instead of concrete or asphalt, the surface consists entirely of interlocking steel panels. Each panel measures 10 feet long by 15 inches wide, constructed from 10-gauge low-carbon steel. The distinctive feature: 87 precisely punched holes arranged in 3 rows running the length of each panel, the edges of each hole flanged upward to create structural strength. Hooks run along one long edge, slots along the other, allowing adjacent panels to connect and lock together. The installation took 11 days, remarkably fast by conventional standards, but still too slow for battlefield conditions. Yet the concept was revolutionary enough to attract the attention of General Henry H. Arnold, Chief of the United States Air Corps. Arnold walked the length of the experimental strip, observing how the panels distributed the weight of aircraft across the underlying soil, how the perforations provided drainage while reducing the weight of each panel by 17.5% compared to solid steel alternatives. "This is the year's greatest achievement in aviation warfare," Arnold declared. The technology had been years in development. In December 1939, the Army Corps of Engineers received the formal design directive for what would become the Marston Mat. The British and French had been experimenting with similar concepts, the British using heavy wire mesh, the French employing steel chevron grids, but analysis revealed both designs unsuitable for American needs. The British version couldn't withstand the takeoffs and landings of heavy bombers and would be difficult to repair after battle damage. The French design was too heavy and cumbersome to transport and install quickly. Carnegie Illinois Steel Company took on the challenge, with specialty engineer Gerald G. Grulich leading the design effort. The initial prototypes, tested at Langley Field in summer 1940, were solid-ribbed steel, strong but prohibitively heavy. Through the winter of 1940-1941, the design evolved. The distinctive punched holes emerged not just for drainage, but to dramatically reduce weight while maintaining load-bearing capacity. The final M8 specification called for panels that a single soldier could handle and position, 10 feet long, 15 inches wide, approximately 66 pounds each, with 87 perforations providing drainage and reducing material costs. Mass production began in late 1941. By December 1941, 2 factories had already produced 4 million square feet of matting. As America entered the war, production ramped dramatically. Eventually, 29 facilities across the United States would manufacture Marston Mat, churning out panels by the millions. The interlocking system was elegantly simple. Hooks pressed 90 degrees to the mat surface engaged slots on adjacent panels, secured by steel clips. The entire assembly could be laid by unskilled labor using only sledgehammers. The first wartime deployment came in early 1942, not in the Pacific, but in Greenland. At Bluey West 1 airfield, construction crews laid a 5,000-foot runway using pierced steel planking over frozen ground near Narsarsuaq. Construction began in early fall 1941, and the first aircraft landed on January 24, 1942. The success of this installation validated the concept. PSP could function in extreme conditions: Arctic cold, tropical heat, on sand, mud, coral, even frozen tundra. But the true test would come in the Solomon Islands, where American forces were about to make their first offensive thrust in the Pacific War. August 7, 1942, Guadalcanal, Solomon Islands. The 1st Marine Division storms ashore at Red Beach and advances inland toward Lunga Point. Their immediate objective, a nearly completed Japanese airfield that reconnaissance has been monitoring for weeks. The Japanese had been constructing the facility since early July, employing over 2,500 workers, construction crews, civilians, and military specialists installing radio equipment and search radar. The Japanese called it Lunga Point Airfield. On August 8th, C Company 1st Marines, commanded by Captain Nikolai Stevenson, captured the airstrip. The Japanese had fled so hastily they left construction equipment behind. The Marines renamed it Henderson Field in honor of Marine Major Lofton Henderson, killed at Midway. What they captured was essentially a dirt runway, 3,778 feet long, 150 feet wide, rolled dirt and gravel with minimal infrastructure. Vulnerable, inadequate. The 6th Naval Construction Battalion, the Seabees, went to work immediately. Their first priority, make Henderson Field operational for fighters and dive bombers. The initial effort focused on lengthening and grading the existing runway, but the real transformation began when Marston Mat arrived in September 1942. Initially, only about 1,000 feet of the runway received steel matting, enough to provide a critical hard surface for takeoffs and landings, dramatically reducing the damage from constant aircraft operations. The rest remained compacted coral and dirt. The difference was immediate and obvious. When tropical rains turned the unimproved sections into mud, aircraft bogged down, nosed over, or simply couldn't operate. The Marston Mat sections remained firm, draining water through the perforations, the flanged holes creating traction for aircraft tires. Damaged fighters could dead stick land on the matted surface with reasonable confidence. Major John Smith, commanding VMF 223, later explained the field's importance. If they shot one of us down and the plane didn't burn, we went in and had a dead stick landing on the field. If the plane burned, our pilots jumped out over the field and were saved. The Japanese recognized the strategic importance immediately. They launched assault after assault to recapture Henderson Field. The Battle of the Tanaru on August 21, the Battle of Edson's Ridge on September 12 through 14. Each attempt failed, but each also demonstrated the vulnerability of the airfield itself. Japanese warships bombarded the strip regularly. Bombs cratered the runway, and every time the Seabees repaired the damage. Commander Joseph P. Blunden described the repair system they developed. We found that 100 Seabees could repair the damage of a 500-pound bomb hit on an airstrip in 40 minutes, including the replacing of the Marston Mat. In other words, 40 minutes after that bomb exploded, you couldn't tell that the airstrip had ever been hit. The Seabees established repair stations every 1,000 feet along Henderson Field, each with foxholes for the crews and pre-positioned stacks of Marston Mat, 1,600 square feet per station, the amount experience showed was necessary to repair a typical bomb hit. Our worst moments were when the Jap bomb or shell failed to explode when it hit, Blunden recalled. It still tore up our mat, and it had to come out. By late 1942, the pattern was established across the Pacific. Wherever American forces captured or secured territory, Marston Mat appeared within days. Milne Bay, Papua New Guinea, September 1942, a Curtiss P-40 Warhawk taxis along steel matting laid between coconut palms. The Aleutians, where Navy Construction Battalion 45 laid mat on Tenaga Island's auxiliary field despite Arctic conditions. Fighter strips proliferated across the Solomon Islands chain as American forces advanced northward. The Japanese began to realize they had miscalculated. Their defensive plans assumed American airfields would require substantial construction time, concrete runways poured and cured, drainage systems installed, extensive grading and preparation. Instead, American forces were establishing operational airfields within 72 hours of securing a landing site. The strategic implication was profound. American air power could advance almost as fast as ground forces could capture territory. June 15, 1944. The Battle of Saipan begins, with the largest amphibious assault in the Pacific War to date. Over 60,000 American troops, primarily the 2nd and 4th Marine Divisions, storm ashore against approximately 30,000 Japanese defenders. The strategic objective extends far beyond the island itself. Saipan is 1,500 miles from Tokyo, within range of the new B-29 Superfortress bomber. Capturing Saipan means capturing the ability to strike the Japanese home islands directly and repeatedly. On June 16 to 17, just 2 days into the invasion, Marines captured Aslito Airfield, a Japanese facility that had been under construction since 1937. During the final Japanese defense, Commander Robert H. Isley's TBF Avenger was hit by anti-aircraft fire and crashed on the south side of the runway on June 13, killing Isley and his crew. When Marines finally secured the airfield, they renamed it Isley Field in his honor. But merely capturing the airfield was insufficient. The Japanese runways were inadequate for B-29 operations. The Superfortress required substantially longer and stronger runways than any previous aircraft. Each B-29 weighed approximately 65 tons when fully loaded with fuel and bombs. Taking off required 8,500 to 9,000 feet of runway. The existing Aslito facility couldn't handle such aircraft. Here, the mathematics of logistical capability determined strategic outcomes. Conventional runway construction, pouring and curing concrete for a B-29 capable airfield would require months. The Marines had taken Saipan, but Japanese forces still controlled Iwo Jima, 600 miles to the north, from which they could launch air attacks against American positions. Ground troops were still rooting out Japanese holdouts across Saipan's rugged terrain. The island was secure enough to begin construction, but vulnerable enough that time was critical. The Seabees and Army Air Force engineers went to work transforming Isley Field into a B-29 base. Naval Construction Battalion personnel, including the 3rd Battalion, 20th Marines, began the massive expansion project. The challenge was immense, extending runways to 9,000 feet, constructing taxiways and hard stands capable of supporting dozens of superfortresses, creating infrastructure for fuel storage, munitions, maintenance facilities, and housing for thousands of personnel.
The solution arrived in the cargo holds of Liberty ships. Thousands of tons of Marston Mat, pre-manufactured in American steel mills, transported across the Pacific, ready to be deployed. While concrete would require weeks to cure properly, Marston Mat could be laid over prepared coral surfaces in days. Construction crews cleared the jungle, graded the land, and crushed coral to create a stable base. Then came the mat, panel by panel, section by section, the distinctive clang of hammering echoing across what had been battlefield only weeks earlier. Teams of Seabees worked around the clock, the panels interlocked in staggered patterns, hooks engaging slots, each section locked to its neighbors to distribute the enormous loads that B-29s would impose during takeoff and landing. The first B-29 of the 73rd Bombardment Wing arrived at Isley Field on October 12, 1944, just 4 months after the initial invasion. Additional groups of the 497th, 498th, 499th, and 500th Bombardment Groups followed in early November. By November 22, more than 100 B-29 Superfortresses were stationed at Isley Field, each one capable of carrying 10 tons of bombs to Tokyo and back. Across the Marianas, similar transformations occurred at incredible speed. On Tinian, just 3 miles from Saipan, Seabees constructed North Field, ultimately home to 4 runways and capable of accommodating over 200 B-29s. 6 miles of taxiways connected hard stands to runways. The entire complex, built largely on Marston Mat over crushed coral, became operational within months of the island's capture. On Guam, Harmon Field and North Field provided additional B-29 basing. November 24, 1944, the first B-29 raid launched from the Marianas struck Tokyo. 21st Bomber Command dispatched 111 superfortresses from Saipan, Tinian, and Guam. Not all made it to the target due to mechanical issues, a persistent problem with the complex B-29, but the strategic shift was undeniable. American heavy bombers now operated from bases just 1,500 miles from the Japanese capital, capable of sustained campaigns against Japanese industry, ports, and cities.
The Japanese response revealed their desperation. On November 2nd, Imperial Japanese Navy G-4M Betty bombers flying from Iwo Jima struck Isley Field at low altitude around 1:30 a.m., damaging several B-29s. Construction lights were still burning, testament to the continuous expansion work underway.
On November 27th, 2 more G-4Ms hit Isley Field in the early morning hours, destroying 1 B-29 and damaging 11 others. Later that same day, 12 Mitsubishi A-6M0 fighters equipped with bombs struck at noon, destroying 3 or 4 B-29s and damaging up to 2 more. One Japanese pilot actually landed his Zero on Isley Field and opened fire on personnel with his pistol until he was killed by rifle fire. Brigadier General Hansel personally witnessed the attack, but 40 minutes after each bomb crater appeared, the Seabees had it patched. The B-29s continued flying.
The genius of Marston Mat lay not in technological sophistication but in understanding the fundamental problem of projecting air power across the Pacific. The requirements had been clear from the start. The United States needed to rapidly construct airfields on captured territory, islands, atolls, and coastal areas where conventional construction would be impossible or prohibitively slow. The terrain varied wildly: coral atolls, volcanic sand, jungle mud, Arctic tundra. The airfields had to support increasingly heavy aircraft, from P-38 fighters to B-24 Liberators to the massive B-29 Superfortress. They had to be deployable by relatively unskilled labor under combat conditions. They had to be repairable quickly when damaged by enemy action. And they had to be transportable, meaning the material itself couldn't be so heavy or bulky that shipping space became prohibitive. Gerald G. Grulich and the Carnegie Illinois Steel Company engineers faced a classic engineering trade-off. Solid steel planking could easily support any aircraft but would be too heavy, both for individual soldiers to handle and for ships to transport in the quantities required. Lighter materials like aluminum were possible, and later aluminum versions were produced, but aluminum was a strategic material needed for aircraft production, and its wear characteristics were inferior to steel. The ideal solution needed to be strong enough to support 65-ton bombers, light enough for one man to lift in position, cheap enough to produce by the millions, and simple enough to install without specialized equipment. The mathematics were brutally simple. A solid steel plank 10 feet long, 15 inches wide, and thick enough to support bomber loads would weigh approximately 80 pounds or more, approaching the limit of what a single soldier could handle repeatedly over a 12-hour shift. But punch 87 precisely sized holes in that plank and the weight drops to 66 pounds, a 17.5% reduction, while the flanged edges of those holes actually increase structural strength by creating a corrugated effect. The perforations also provided critical drainage, allowing water to pass through rather than pooling on the surface, and the holes reduced dust generation compared to solid surfaces. The interlocking system was equally elegant. Hooks pressed 90 degrees along one edge engaged slots on the opposite edge of adjacent panels. Simple steel clips locked the connections, no welding required.
No specialized tools beyond sledgehammers. The panels could be laid by combat engineers, Seabees, or even infantry with minimal training. If a section was damaged, it could be pried up and replaced without disturbing surrounding panels. The design philosophy reflected a fundamentally American approach to warfare, industrial mass production solving tactical problems. The M8 specification called for standardized panels that any steel mill could produce. By 1944, 29 facilities across the United States were manufacturing Marston Mat. The scale was staggering. Approximately 2 million tons of PSP were produced during World War II, enough steel to construct roughly 600 Liberty ships, or alternately, enough matting to build a 100-foot-wide runway from San Francisco to Berlin if laid end-to-end. Production costs exceeded $200 million in 1940s dollars, but the strategic value was incalculable. Each Liberty ship could transport enough Marston Mat in a single cargo hold to construct a complete operational airfield, typically 3,000 to 5,000 feet of runway, plus taxiways and hardstands. LSTs, landing ship, tank, delivered matting directly to invasion beaches. Within 72 hours of securing a beachhead, American forces could have an operational fighter strip. Within a week, a bomber-capable field. The alternative,
Conventional concrete construction required specialized equipment, skilled labor, extensive time for curing, and vulnerability during the construction period. Concrete runways couldn't be repaired quickly after bomb damage. They required established supply lines for cement, water, and aggregate. In the rapid island-hopping campaigns of the Pacific War, those delays were unacceptable. The Japanese had no equivalent. They developed experimental runway matting in 1942 and deployed some at Rabaul, but lacked both the industrial capacity and logistical capability to implement it on the scale American forces achieved. Japanese defensive planning consistently underestimated how quickly Americans could establish operational airfields. That miscalculation cost them control of the air, which in turn cost them control of the seas, which ultimately cost them the war. The strategic impact of Marston Mat manifested across every theater where American forces operated, but nowhere more decisively than in the Pacific. Henderson Field, Guadalcanal, September 1942 through February 1943. The Cactus Air Force, Marine, Navy, and Army Air Force squadrons operating from Henderson flew continuous missions despite Japanese attempts to render the field inoperable. Commander Blunden's repair crews patched bomb damage in 40 minutes. When heavy rains turned unimproved sections into mud, the Marston Mat sections remained operational. Captain Marion Carl of VMF 223 remarked on the field's challenging conditions. It was widely held that Guadalcanal was the only place on Earth where you could stand up to your knees in mud and still get dust in your eyes. Yet despite those conditions, Henderson Field supported sustained operations that proved decisive in the Guadalcanal Campaign. New Guinea, 1943. As Allied forces advanced along the northern coast, airfields appeared with remarkable speed. Milne Bay, September 1942. Port Moresby expansions, smaller fighter strips at Dobodura, Nadzab, and dozens of other locations, each one built in days using Marston Mat over local terrain. The rapidity of airfield construction allowed Allied air forces to maintain constant pressure on Japanese positions, supporting ground advances and interdicting Japanese supply lines. The Marians, 1944. The transformation of Saipan, Tinian, and Guam into B-29 bases represented the apex of Marston Mat's strategic importance. By mid-1945, North Field on Guam alone accommodated over 200 B-29s, with 6 miles of taxiways linking hardstands to runways. The infrastructure required to support hundreds of superfortresses, each aircraft requiring extensive maintenance, fuel, munitions, and crew facilities, had been established in months rather than years. From these bases, 21st Bomber Command launched the strategic bombing campaign that devastated Japan's industrial capacity and urban areas. The first incendiary raid on Tokyo, March 9–10, 1945, involved 334 B-29s and created a firestorm that killed an estimated 80,000 to 100,000 people. Subsequent raids struck Nagoya, Osaka, Kobe, Yokohama, and dozens of other cities. By August 1945, Japan's capacity to continue the war had been systematically destroyed. None of this would have been possible without the ability to rapidly establish and maintain bomber bases across the Pacific. The B-29s required extensive runway infrastructure, 9,000-foot runways capable of supporting 65-ton aircraft repeatedly, day after day, mission after mission. Marston Mat provided that capability in timeframes that conventional construction could never match. The Normandy invasion, June 1944. While less celebrated in the Pacific context, Marston Mat played a crucial role in Europe as well. Immediately following D-Day, Army Air Force engineers laid temporary airstrips using PSP on Norman beaches and inland areas. These rapidly constructed fields allowed tactical air units to provide close air support for advancing ground forces without waiting for established airfields to be repaired or constructed. A C-47 Skytrain became the first aircraft to land on a steel mat runway in France after the invasion. Throughout the European campaign, PSP provided temporary airfields, roads, and vehicle parking areas that accelerated the Allied advance. Statistical accounting remains incomplete, but available records indicate that by 1944, over 180 million square feet of Marston Mat had been laid worldwide, equivalent to more than 14 million individual panels. In the Solomon Islands alone, crews of 100 to 150 men were documented laying 70 to 115 square feet of matting per worker hour, enabling construction of a 6,000-foot runway in approximately 4.5 days. Later in the war, with refined techniques and experienced crews, a 3,000-foot runway could be completed in under 72 hours from the moment of unloading. The Berlin Airlift, 1948-1949. Even after World War II ended, Marston Mat continued proving its worth. When the Soviet Union blockaded West Berlin, U.S. forces rapidly deployed PSP to reinforce runways at Tempelhof Airport, enabling Douglas C-47 and C-54 cargo aircraft to maintain the airlift. The existing PSP runways, originally designed for fighters and lighter aircraft, struggled under the constant pounding of heavily loaded transports, over 278,000 flights delivering 2.3 million tons of supplies, but they held long enough for permanent concrete overlays to be constructed. The Korean War, Vietnam, Afghanistan, Marston Mat and its descendants, particularly the AM2 aluminum matting developed in the 1960s, continued serving in every subsequent American conflict. The fundamental problem remained unchanged: how to rapidly establish airfields on unprepared terrain under combat conditions.
The solution, first deployed at Marston, North Carolina in November 1941, proved enduringly effective.
The numbers tell the story of American industrial capability applied to tactical necessity.
Production statistics. Total production, approximately 2 million tons of pierced steel planking. Production cost, over $200 million, 1940s dollars. Number of manufacturing facilities, 29 plants across the United States by 1944. Initial production capacity, December 1941, 4 million square feet from 2 facilities. Peak wartime production, sufficient to construct hundreds of airfields. M8 Marston Mat. Specifications. Length, 10 feet, 3 meters. Width, 15 inches, 0.38 meters. Material, 10-gauge low-carbon steel, approximately 0.25 inches thick. Weight per panel, 66 pounds, 30 kilograms. Perforations, 87 holes per panel, 3 wide by 29 long. Load capacity, designed to support aircraft up to 125,000 pounds. Installation method, interlocking hooks and slots, secured with clips. M9 aluminum variant. Weight per panel, approximately 32 pounds, reducing handling strain and shipping weight. Material, aluminum alloy, 0.156 inches thick. Load cycles, approximately half of that of steel version. Production volume, limited due to aluminum being strategic material for aircraft production. Typical use, remote airfields where weight savings justified reduced durability. Construction capabilities. Initial installation time, 1941, 11 days for 3,000-foot runway, Camp McCall demonstration. Early war Pacific construction time, 4.5 days for 6,000-foot runway in the Solomon Islands. Late war construction time, under 72 hours for 3,000-foot runway with experienced crews. Bomb damage repair time, 40 minutes for a 500-pound bomb crater, 100-man Seabees crew. Required labor, 100 to 150 personnel could lay 70 to 115 square feet per worker hour. Shipping efficiency, single Liberty ship cargo hold could transport complete airfield. Major installations, Henderson Field, Guadalcanal, initial 1,000 feet matted in September 1942. Isley Field, Saipan, 8,500-foot B-29 capable runway, October 1944. North Field, Tinian, 4 runways, 200-plus B-29 capacity with 6 miles of taxiways. North Field, Guam, similar capacity to Tinian facility. Bluey West 1, Greenland, 5,000-foot runway, first operational deployment, January 1942. Numerous fighter strips, dozens of 3,000 to 5,000-foot installations across Pacific Islands. European theater,
temporary airfields in France, Italy, North Africa. Total global deployment over 180 million square feet by 1944. Strategic comparisons. Conventional concrete construction. Time to cure, 28 days for full strength. Required materials, Portland cement, aggregate, water, all requiring transport. Repair time after bomb damage, days to weeks depending on extent. Equipment required, mixers, graders, finishing equipment, skilled labor. Vulnerability during construction, high, weeks of exposure before operational. Marston Mat construction. Time to operational status, 72 hours with experienced crews. Required materials, prefabricated panels, manufactured in USA and shipped. Repair time after bomb damage, 40 minutes for typical bomb crater. Equipment required, sledgehammers, clips, basic grading equipment. Vulnerability during construction, low, rapid installation reduces exposure. The philosophical difference. The Marston Mat represented a fundamentally different approach to wartime logistics.
Rather than attempting to construct permanent facilities under combat conditions, American forces deployed prefabricated, standardized components that could be rapidly assembled, easily maintained, and quickly repaired. The underlying philosophy valued speed and flexibility over permanence. This approach reflected broader American military doctrine, overwhelming industrial capacity deployed with logistical sophistication. The Japanese planned their Pacific defense assuming American airfields would require substantial time to construct, providing windows for counterattack. That assumption proved fatally flawed. American forces could establish operational airfields faster than Japanese forces could mount effective operations against them. The cost-benefit analysis was overwhelming. 2 million tons of steel converted into Marston Mat enabled the construction of hundreds of airfields across the Pacific and European theaters. Those airfields, in turn, enabled tens of thousands of bomber and fighter sorties. Each sortie degraded Japanese and German military capacity. The accumulation of thousands of sorties, made possible only by the rapid airfield construction that Marston Mat enabled, proved decisive in achieving air superiority and, ultimately, victory. November 27, 1944, late afternoon, Isley Field, Saipan. Brigadier General Hansel stands once again at the edge of the runway, but this time watching as B-29s return from the second Tokyo raid. The engine's drone grows louder as the first Superfortress enters the landing pattern. Landing gear drops. The aircraft descends, touches down on the steel matting, and rolls out safely. Another follows, then another. 72 B-29s departed on this mission. The raid accomplished little. Cloud cover obscured targets, forcing radar bombing that scattered results. But the strategic impact extends far beyond today's bomb damage assessment. The aircraft returned successfully to bases built in months, operating from runways constructed in days. The Japanese now face an opponent capable of establishing air power projection platforms faster than conventional military planning could anticipate. Across the Pacific, the pattern repeats. Henderson Field, where the Cactus Air Force held Guadalcanal against desperate Japanese attempts to recapture it. The massive bomber complexes on Tinian and Guam, where hundreds of B-29s prepare for missions that will systematically destroy Japan's capacity to wage war. Smaller fighter strips scattered across dozens of islands, each one enabling American air superiority over an expanding sphere of operations. The irony is striking. The weapon that truly won the Pacific Campaign wasn't a bomber or a battleship or even the atomic bomb. It was a 66-pound steel plank punched with 87 holes, designed to be installed by unskilled labor using sledgehammers. The Japanese had planned for a different war, a war where geography provided defense, where island fortresses could hold out long enough for American logistics to falter, where the vast distances of the Pacific would exhaust American capabilities before reaching Japan itself. They had not planned for Marston Mat. They had not anticipated that American forces could build heavy bomber bases on coral atolls within months of capturing them, that bomb-damaged runways could be repaired in 40 minutes, that the steel carpet would roll inexorably westward toward Tokyo regardless of terrain, weather, or enemy action.
General Arnold had been correct in November 1941 when he called the Marston Mat demonstration the year's greatest achievement in aviation warfare. But even Arnold likely didn't foresee the full scope of its impact.
By enabling rapid airfield construction, Marston Mat enabled American air superiority. By enabling American air superiority, it enabled the island-hopping campaign. By enabling the island-hopping campaign, it enabled B-29 raids on Japan. By enabling those raids, it helped force Japanese surrender. After the war, nearly 2 million tons of surplus Marston Mat remained scattered across former battlefields. Local populations repurposed it extensively. In the Philippines, miles of distinctive perforated steel fencing still stand, monuments to a technology that literally paved the road to victory. In Papua New Guinea, sections form walls and gates. American farmers collected abandoned panels to build durable fences. Italian and French communities used them for road construction. The material's high manganese content resisted corrosion, allowing these wartime artifacts to survive decades of service in civilian applications. But the true legacy of Marston Mat lies not in its post-war repurposing, but in the strategic revolution it enabled. Modern military planning still confronts the same fundamental challenge: how to rapidly establish air power projection capabilities in austere environments. The solutions have evolved: AM2 aluminum matting in Vietnam, modern composite materials in Afghanistan, but the underlying problem remains unchanged. Ground forces must secure territory. Air forces must establish bases. Speed matters. The lesson of Marston Mat transcends its specific tactical application. It demonstrates that victory in modern warfare often depends not on the most advanced weapons, but on the most effective logistics, not on the biggest gun, but on the smartest solution to the fundamental problem of getting forces into position to fight effectively. The Japanese built formidable defenses, fielded experienced troops, and fought with determination and skill. They lost anyway, because American forces could establish airfields faster than Japanese defensive planning anticipated. The examination of Isley Field on Saipan, the repair crews working through the night to patch bomb craters, the B-29s returning safely from Tokyo, these scenes captured a larger truth about American military capability in World War II. The United States didn't just outfight its enemies, it outbuilt them, out-transported them, out-repaired them, and out-sustained them. And a significant portion of that logistical dominance came down to 66 pounds of perforated steel, mass-produced by the millions, transported across oceans, and laid panel by panel across coral sand. The Marston Mat was not glamorous. It didn't fly, it didn't shoot, it didn't explode, but by conquering mud, sand, and coral, it allowed American air power to be deployed anywhere, anytime, faster than the enemy could react. In that single capability lies the entire story of why America won the Pacific War, and the enduring lesson that in warfare, logistics isn't just important, sometimes it's everything.